Hello. Today we are looking at a problem that we are going to solve using Bayes' theorem, and it's here. So this is our example for today. So in screening for a certain disease, the probability that a healthy person wrongly gets a positive result is 0.05. The probability that a deceased person or a person with a disease wrongly gets a negative result is 0.002. So the rate of the disease in the population being screened is 1%. If my test gives a positive result, what is the probability that I actually have the disease? So this is a problem that we are going to solve using Bayes' theorem. So the first thing we need to note that we have a set of mutually exclusive and exhaustive events. The event of having the disease and not having the disease. So we could start by first of all saying let D be the event of having the disease. Then we let D prime be the event of not having the disease. So we are going to write it as D complement or D prime. Then we let P, don't need to repeat the let. So we let P be probability, the event of getting a positive result. Event of getting a positive result. Event of getting a positive result. And we can also let N be the event of getting a negative result. So first of all, we're saying that we have a set of mutually exclusive and exhaustive events. So we could illustrate this in diagram. We have the event of having the disease, the event of not having the disease. We are told that the rate of having the disease in this particular population is 0.01, implying that the probability of not having the disease is 0.99. And once any person in the population is tested, you can either get a positive result. You can get a positive result when you have the disease. It's also possible to get a positive result when you do not have the disease. Of course, we have been told here that the probability of getting a positive result when you don't have the disease, according to the instructions that we are given up here, is 0.05. It is 0.05. We can actually see it in the information given. It is this. Then the probability that a person wrongly gets a negative result is 0.002. So we come to our diagram. So the probability of wrongly getting a negative result when you have the disease is 0.002, meaning that the probability of getting the disease, a positive result when you have the disease, is the complement of this, so it's going to be 0.998. So this is put here, 0.998. Okay, so now what do we require? We require to get, we are told if my test gives a positive result, what is the probability that I actually have the disease? If my test is positive, what is the probability that I actually have the disease? So we are looking for probability that I have the disease if the result is positive. This is what we are looking for. So what we need, first of all, is to get the probability of getting a positive result. So probability of getting a positive result is a total probability. It is probability of getting the disease. It's the probability of having the disease and getting a positive result, plus probability of not having the disease and getting a positive result. So now, introducing conditional probability, we have probability of getting a positive result is probability of having the disease times probability of having the disease, times probability of getting a positive result given that you have the disease, plus probability of not having the disease times probability of getting positive result when you do not have the disease. So we come to our diagram and replace those probabilities. So probability of getting a person with the disease is 0.01. Probability of positive result when you have the disease is 0.998 plus, so put that together, probability of not having the disease is 0.99, which we now multiply by probability of getting a positive result when you don't have the disease, which is 0.05. So if we work that out and put that together, we are going to get 0.05948. You can actually confirm that. So we have that, which is a total probability. But now, remember, we need to get the probability that I have the disease given the result is positive. That's what we are going to work out now. That's what we are going to work out now. The probability of having the disease, the probability that I have the disease given the result is positive. So what I'm going to do, first of all, I'm going to clear my board. First of all, clear my board so that I can have some space to write. So we already know that the probability of getting a positive result is 0.05948. So allow me to clear that. So now we are looking for probability of having the disease given the result is positive. This is equal to probability of having the disease and you are positive over probability of positive result. This is conditional probability. So you remember the denominator is a total probability. So the numerator is probability of disease times probability of having the disease given that times the probability of getting positive result given you have the disease over probability of getting a positive result. Remember, we already know the probability of getting a positive result. So what we need to do is get the probability of a person having the disease. Probability of a person having the disease is 0.01 times probability of being positive given that you have the disease is 0.998, and this we are going to divide by the total probability that we have already found, which is 0.05948. So putting that together and dividing, confirm that we have the probability that I have the disease given I have been given positive result is 0.168. So that is how we solve problems using Bayes' theorem. First of all, we need to note that we use Bayes' theorem when we have two mutually exclusive and exhaustive events, and we have another event P that cuts across the two. Here the mutually exclusive events are the event of having the disease and the event of not having the disease. And the event that cuts across them is the probability of getting a positive result. So, thank you.